Hi guys, in this video we're going to talk about how to calculate percent abundance and average atomic mass when given a story problem instead of a model to look at. So let's begin. It says an element, bromine, has two known isotopes. It says bromine 81 and 79. A sample of bromine was analyzed with a spectrophotometer and was found to have 510 atoms of bromine 79 and 490 of bromine 81. Calculate the percent abundance for each. So let me actually use a couple of different colors. So we have two different isotopes. So I'm going to do one in pink and the other in blue. So it tells us that we have a total of 510 atoms with a mass of 79, and we have 490 atoms with a mass of 81. So we need to find the total number of atoms. So that's the first thing we're going to do. So we have 510 of the one kind plus 490 of the other. So if we add that together, 510 and 490, that is 1,000 total atoms. Okay, now it tells us that 510 of them have a mass of 79 out of my total 1,000. Okay, then I'm going to multiply that by 100 to get my percent. So 510 divided by 1,000, I'm going to put it into my calculator. So 510 divided by 1,000 total atoms times 100 tells us that my percent is 51%. Has a mass of 79. So BR-79. Now I'm going to do the same thing. And here I've got 490 atoms out of my grand total of 1,000. I'm going to multiply that by 100. And my percent for this one, 490 divided by 1,000 times 100 gives me 49%. These two add up to 100, so we're good. And this is bromine 81. Okay, so then down here it says calculate the average atomic mass. So what I'm going to do is I'm going to take the mass of the first, which is 79, times its percent, which is 51. I'm going to add that to my second isotope, which has a mass of 81, times its percent, which is 49. And then I'm going to divide this whole thing by 100. And that's going to give me my average atomic mass. So I type that into the calculator. I make sure to do the top first before I divide. So 79 times 51 plus 81 times 49, enter. So I hit enter, then I'm going to go divided by 100, and I get 79.98. Whoops, 98 grams. I'm going to look on the periodic table at bromine. So bromine is right here. Where are you at, bromine? Wrong side of the periodic table. Bromine is right here, and it's 79.9, which is really darn close, 79.98. Okay, we're going to do these practice problems over here. So in all of these, they give you the percent abundance. So we're not going to do a percent abundance calculation. These are just average atomic mass. So it says gallium has two naturally occurring isotopes, gallium-69 with abundance of 60.11%. Okay, so for that, I'm going to do 69 times 60.11 plus, my second one has a mass of 71 and its abundance is 39.89. So I'm going to do 71 times my 39.89. Okay, so that's supposed to be a 1. Okay. So then once I do that, I'm going to take all of this and divide it by 100, and that will give me my mass. So I'm going to put that into the calculator. So I'm going to type 69 times 60.11 plus 71 times 39.89. 39.89, hit enter, divide by 100, and I get 69.79. So about 69.8. And if I look on the periodic table, gallium is Ga, gallium is right here, and we can see it's 69.7, so we were really darn close, 69.79. Okay, so then down here it says calculate the average atomic mass of sulfur. If 95% of all sulfur atoms have a mass of 31.972, so I'm going to take 95% times its mass, which is 31.972, plus I have another isotope, which is 0.76%, so 0.76 times a mass of 32.971, plus my final one, 4.22% has a mass of 33.967. We're running out of space, times 33.967. Okay, this whole thing is going to get divided by 100. So this one's a little sloppy. Sorry, friends. So what I'm going to do here, so I'm going to put that all on my calculator. So 95 times 31.972 plus 0.76 times 32.971 plus 4.22 times 33.967, and I hit enter, and then I'm going to divide by 100, hit enter, and I get 32.05. And if I look on the periodic table for sulfur, we got really close, 32.06. Actually, if we look here, that 7 would round that up to 6, so I got that wrong. So 32.06. Okay, final practice. This one doesn't take calculation. It says argon has 3 naturally occurring isotopes, 36, 38, and 40. Based on argon's reported atomic mass, which one do you think is most abundant? So if I look, here's argon. Its reported mass is 39.95. So that's pretty darn close to 40, right? You guys can see that, 39.95. So I would say that argon 40 is the most abundant because that is closest in mass to the average. So argon 40 is the most abundant. Because the average mass, so average atomic mass is closest in value to 40. Okay, all done.